Okay, so today we will be talking about AMU, atomic mass unit. So we will start this topic today, but first let's talk about what we learned yesterday in the fourth part of this series matter, and this is the fifth part. If you haven't watched the first and all those previous part of this series, then go ahead, watch those part. I'll maybe give you the link below. And now let's start this topic, AMU. So yesterday we learned about electron, proton and neutron. Electron, proton and neutron. So here electron, they are negatively charged particles, E minus. So why its power is minus? Because it represents that they have a negative charge. They are negatively charged particle. Proton, they are positively charged particle, P plus. And then we have what? Neutron. Neutron, they are chargeless. They don't have any kind of charge. N 0. So we learned about these three things in yesterday. Okay, so if you want to get more information in detail about these three things, then you have to watch all the three previous part of this series. And today let's start our topic by AMU, atomic mass unit. Okay, here we have atomic mass unit, and as you guys already know, the atoms are very small, right? So we can't measure their mass in gram or like milligram, because they are really small. So gram and milligram, we can't measure their mass in gram and milligram. The mass of an atom is extremely small, so that is why we can't measure their mass in gram or milligram. And because of this reason, the mass of an atom is measured in atomic mass unit, right? Like I already said, the atoms, they are really small. The mass of an atom is extremely small, so we can't measure in gram or milligram because they are very small thing, atom. And because of this reason, because of this reason, the mass of an atom is measured in atomic mass unit, right? The mass of one hydrogen atom is 1 AMU. The mass of one hydrogen atom, let me write here, hydrogen, HYDROZE, and hydrogen atom is mass of one hydrogen atom. Mass of one hydrogen atom is what? 1 AMU. Mass of one hydrogen atom is 1 AMU, 1 atomic mass unit. Mass of one hydrogen atom, mass of one hydrogen, HYDROZEN, this is the spelling, atom is 1 AMU. So the mass of a single hydrogen atom is what? 1 AMU. AMU is a unit that is used to measure mass. Like I already said, that we can't measure atom in gram or milligram because they are extremely small, right? And because of this reason, they are measured in AMU, atomic mass unit, right? So mass of one hydrogen atom is 1 AMU, right? Okay. 1 gram is equal to 6 times 10 to the power 23 AMU. 1 gram is equal to 6 times 10 to the power 23 AMU. So this is 1 gram, 1 gram is how much AMU? 6 times 10 to the power 23 AMU. This is 1 gram. If you write 1 gram in AMU, atomic mass unit, then you will get this thing. 6 times 10 to the power 23 AMU. You have to remember this because maybe it will ask you in your exam that how much is 1 gram. Like in multiple choice question, you have to tick the right question. So maybe it can give you in the exam and you have to choose the right answer. So remember this, 1 gram is how much? 6 to the power 23 AMU. 6 to the power, yeah, 6 times 10 to the power 23 AMU. 6 times 10 to the power 23 atomic mass unit. Okay, and the mass of a proton is nearly equal to the mass of one hydrogen atom. It is not totally equal, it is nearly equal, right? Almost equal, right? It is not total equal, it is almost equal to one hydrogen atom. So the mass of proton, I can maybe write it over here. What is going on? First let me explain you everything, then after that I'm gonna make the notes for you guys. Okay, so mass of one proton, the mass of a proton is nearly equal to one hydrogen atom. So mass of a proton is nearly equal to one hydrogen atom. Okay, it is not totally equal, it is almost or nearly equal to hydrogen atom. One hydrogen atom is, nearly equal to, the mass of one proton is nearly equal to the mass of one hydrogen atom, right? It is not totally equal. Like here 2 plus 2, you know these two are equal. Yeah, 2 is equal to 2. They are very totally equal, but here they are almost equal. Mass of a proton and hydrogen atom, they are nearly or almost equal. So here, like I already told you, that the mass of one hydrogen atom is 1 AMU. So we can also say that the mass of one proton is nearly 1 AMU, right? Because I already told you that mass of a proton is nearly equal to 1 AMU, means mass of one hydrogen atom. So mass of one hydrogen atom is 1 AMU. So the also mass of one proton will be nearly 1 AMU. It is not totally 1 AMU, it is only nearly 1 AMU. So we can write here the mass of a proton is about 1 AMU, is about 1 AMU. It is why AMU? Because mass of one hydrogen atom is 1 AMU, so it will be nearly 1 AMU, because mass of a proton, the mass of a proton is nearly equal to the mass of one hydrogen atom. So the mass of one hydrogen atom is 1 AMU. So the mass of a proton will be nearly about 1 AMU. Okay, so this is all about proton, hydrogen atom, and the mass of one neutron is equal to the mass of one proton. Okay, mass of one neutron, the mass of one neutron here, right here, I'm gonna write here mass of one neutron is equal to mass of one proton. Okay, so mass of one neutron is equal to the mass of one neutron. The mass of one proton is equal to the mass of one I mean the mass of one neutron is equal to the mass of one proton. So from here, why are you sneezing? The mass of one proton is 1 AMU, nearly about 1 AMU. So the mass of one neutron, this will be also 1 AMU, right? So you can say that mass of proton, neutron, and mass of one hydrogen, they are nearly equal. 1 AMU, 1 AMU, and 1 AMU, 1 AMU. The mass of neutron is equal to the mass of proton, and the mass of proton is nearly about 1 AMU, which is almost equal to the mass of hydrogen atom, which is also 1 AMU, right? So these are all the connection between these hydrogen atom, neutron, proton, everything, and you need to remember these things because it's science, right? So you need to remember everything of this chapter that I'm teaching you. Okay, so I'm going to also make the note for you guys at the last. So now let's talk about another thing. Okay, we have talked about the mass of one proton, neutron, and the third thing is left is mass of one electron. Like I have in our third or fourth part, I have told you the mass of one electron, which is 1/1837th part of hydrogen atom, right? 1/1837th part of one hydrogen hydrogen atom. This is the mass of what? Then let me write here, mass of one electron is this thing, right? Mass of one electron is 1/1837th part of one hydrogen atom. This is the mass of one electron. So the mass of one electron is equal to about 1/1837th the mass of a proton. I told you the wrong thing, sorry for the mistake. It is proton. You can see in the book, if I show you over here, let me focus a little bit. But the mass of one electron is equal to about 1/1837th the mass of a proton, right? Sorry, it's not hydrogen, it's a proton. Yeah, you can also write hydrogen because mass of one proton is nearly equal to mass of one hydrogen atom. So yeah, it's correct. You can say it's correct because mass of hydrogen atom, mass of hydrogen atom is nearly equal to what? Mass of a proton. Like couple of minutes ago I told you that mass of one hydrogen atom is equal to the mass of a proton, right? These two things are equal, right? So mass of hydrogen atom is equal to mass of one proton. So these two things are almost equal. Mass of a proton is nearly equal to the mass of one hydrogen atom. So and the mass of one electron is 1/1837th part of one hydrogen atom. So we can, from here we can say that in the book it is written that the mass of one electron is 1/1837th part of a proton. So the mass of a proton is equal to the mass of the hydrogen atom. So instead of proton we can also write hydrogen atom, right? Understand? If you have any confusion, then you can tell me. because these two things are equal, so we can write this or this, right? So this is the thing, but here I'm gonna change the thing. I'm gonna write proton because it will be more good. Let me write here mass of what is that? Mass of electron. The mass of one electron is 1/1837th part 1/1837th part 1837 part. Let me write over here again. Okay, the camera was not focused on the whiteboard, sorry for that, but I explained you everything. I hope you'll understand what I explained you. Okay, so the mass of one electron is equal to about, okay, so this is the thing. The mass of one electron is equal to about 1/1837th the mass of a proton, which means we can say that the mass of 1837 electron is equal to the mass of one proton. Like if you have 1837 electron, and if you compare their mass, which will be equal to one proton, right? So the mass of one electron is equal to about 1/1837th the mass of a proton, which means the mass of 1837 electron is equal to the mass of one proton. And okay, so now we have talked about the mass of proton, neutron and electron. From this thing we can conclude this thing, that 1p plus is equal to 1n to the power 0 is equal to 1837 e to the power minus is equal to 1 AMU. 1p plus means you already know that proton, we can write proton, its symbol is p plus, electron its symbol is e minus, and neutron its symbol is n0. So 1 proton is equal to 1 neutron, and these two things is equal to 1837 electron, right? If you take 1837 electron, then their mass will be equal to these two things, right? Their mass will be equal to 1 proton, and is equal to 1 neutron. Okay, and this all thing is called what? 1 AMU. So this is a 1 AMU. 1 AMU is equal to 1p, 1 proton equal to 1 neutron equal to 1837 electron, and these all things form what? 1 AMU. These all things are called 1 AMU. The mass of these all things, when they are equal, is called 1 AMU. And this is the thing. Now some people will think that how this thing came. So this thing came from the thing that we just talked about. I mean, all the masses, the mass of proton is equal to the mass of one hydrogen atom. So let me just revise you everything and tell you how this came. So like you guys already know, like a couple of minutes ago I told you that mass of one hydrogen atom is nearly equal to the mass of one proton, right? Mass of one hydrogen atom is equal to the mass of one proton, and the mass of one proton is equal to the mass of one neutron, right? one neutron, and the mass, and then you can see that the mass of 1837 electron is equal to the mass of one proton. So if you take, we can write here 1837 electron is equal to the mass of 1, this and 0.
No, the first one.
This is hydrogen atom. I mean, just I have imagined this writing atom like this. Let me write here hydrogen, Ha, hydrogen atom. Hydrogen atom is equal to one proton, and one proton, the mass of one hydrogen atom is equal to the mass of one proton, and the mass of one proton is equal to the mass of one neutron, and the mass of one neutron is equal to the mass of 1837 electron. So if you take 1837 electron, then their mass in total will be the mass of one neutron, or the mass of one proton, or the mass of one hydrogen, because these all things are what, equal. And this thing is called 1 AMU. So this is 1 AMU. So I hope everything is cleared. I'm trying very hard to explain you guys. If you didn't understand it still, then you can just watch this video again from the beginning and try to understand everything. Also use your book and watch videos to understand. Okay. Okay. Protons and neutrons, they are charged particles, as you already know, right? Right, or what? Proton, they have what? Plus charge. Electron,
they have minus charge.
Electron, what is electron, they have what? Minus charge. But neutron, it is chargeless. 0, right? So from these three subatomic particles, these two subatomic particles are what? Charged particle, means they have any kind of charge, minus or plus, we don't care about this, but they have any kind of charge, right? Minus charge or plus charge, they are charged particle, and neutron is what? Chargeless, right? Neutron is chargeless. So I'm gonna just wipe this off, neutron, for now, because we will talk about this thing now. Proton and electron. Okay, so proton and electron are charged particle. The electric charge is measured in it is measured in, what is this? Coulomb. COULOMB, coulomb. This is the unit of electric charge. C, we do not denote by C. Coulomb, right? So electric charge is measured in coulomb. Let me write here the electric charge is measured, MEASURED, measured in this thing, coulomb. This is the unit of electric charge. So from here we can write this 1 coulomb, coulomb, C is equal to 6.25 times 10 to the power 6.25 times 10 to the power 18 ESU, which is equal to charge of 6.25 times 10 to the power 18 electrons. Okay, so this is 1 coulomb. One coulomb is this much. 6 times 6.25 times 10 to the power 18 ES this thing is equal to charge of 6.25 times 10 to the power 10 to the power 18 electrons. So this is the what electric charge is measured in what? Electric charge is measured in this thing, right? Electric charge is measured in coulomb. So we can say that 1 coulomb is this much electron. The charge of this much electron is 1 coulomb, right? And here ESU is electrostatic unit. Electrostatic unit. ESU is what? ESU is equal to electrostatic unit. Right now we will not discuss about what is electrostatic unit. In the chapter electricity, maybe we will talk about this. Not maybe, for sure we will talk about coulomb, this all things, but we are in matter right now. So just remember this, that charge of 6.25 times 10 to the power 18 electron is equal to what? 1 coulomb, right? And 1 coulomb is the unit of electric charge. The electric charge is measured in coulomb. Okay, so this is 1 coulomb. So this electric charge, they are not the part of this chapter, electrostatic unit. This is a part of electricity chapter, but still this thing is the part of this chapter. Charge of 6.25 times 10 to the power 18 electrons is equal to this thing. You need to remember this. Okay, remember it. Okay, now let's see what is after this. Okay, now before we go furthermore, let me just make the very perfect note for you guys and summarize all the things that we have studied in this video in one note. Okay, so this is the note. Okay, this is the note for you guys. If you want, you can take the screenshot of this note. It's very hard to make you note for you guys. I have summarized all the things that we learned in this like 30-minute video, almost 30 minutes. Yeah, so this is the note. Let me just again revise all the thing quick, what is written on the note, and then we will end this video. Okay, atomic mass unit. The mass of an atom is extremely small. Yeah, its mass is very small, and the mass of one atom, it can't be measured in gram or milligram. As you guys already know that it's very small, so that's why it can't be measured in gram or milligram, right? Because of this reason, the mass of an atom is measured in atomic mass unit, and that is why the mass of atom is measured in atomic mass unit. Why it is measured in atomic mass unit? Because they are extremely small. It is very difficult, I mean totally impossible to measure atom in gram or milligram. So there is a different unit to measure atoms, atomic mass unit. The mass of one atom is measured, the mass of an atom is measured in atomic mass unit, short form AMU. The mass of one hydrogen atom is 1 AMU. So if you want to know what is 1 AMU, then if you take one hydrogen atom and the mass of that atom is called 1 AMU. So basically 1 AMU is mass of one hydrogen atom. 1 AMU is mass of hydrogen atom, HA, hydrogen atom, short form. So this is 1 AMU is equal to mass of one hydrogen atom. 1 gram is equal to 6 times 10 to the power 23 AMU. 1 gram is equal to 6 times 10 to the power 23 AMU. this is 1 gram. I have written over here and highlighted this with this circle. 1 gram is equal to 6 times 10 to the power 23 AMU. You need to remember this, what is 1 gram, because it can maybe it will ask you in exam in multiple question, like select the correct answer. It will the question will be like, what is 1 gram in what is 1 gram in AMU, and the option will be given and you have to choose this option. 6 times 10 to the power 23 AMU is equal to 1 gram. Okay, the mass of a proton is nearly equal to the mass of one hydrogen atom. The mass of proton is nearly like 1 AMU. Why 1 AMU? Because 1 AMU is equal to the mass of one hydrogen atom. So here I have written the mass of a proton is nearly equal to the mass of one hydrogen atom. It is not totally equal, it is almost or nearly or about equal to one hydrogen atom. So we can say that the mass of one proton is 1 AMU, nearly 1 AMU, right? So the mass of a proton is about AMU. Why AMU? Because the mass of a proton is equal to one hydrogen atom, and one hydrogen atom is equal to 1 AMU. So the mass of a one proton will be also nearly 1 AMU. Okay, the mass of one neutron is equal to the mass of one proton. The mass of one neutron is equal to the mass of one proton. If you take one neutron, and the mass of that neutron is equal to the mass of one proton. Mass of one neutron is equal to the mass of one proton, and instead of proton we can also say that the mass of one neutron is equal to the mass of one hydrogen atom, because the mass of one hydrogen atom is equal to the mass of one proton. So they are equal, these three things are equal, right? Mass of hydrogen atom is equal to proton, one proton, and one proton is equal to one neutron. So we can say that the mass of one neutron is equal to one proton, or mass of one neutron is equal to one hydrogen atom. Okay, let me erase this. Okay, we can say that the mass of where was we here, the mass of one the mass of one neutron is equal to the mass of one proton, but the mass of one electron is equal to about 1/1837 the mass of a proton, right? If focus here, the mass of one electron is equal to about 1/1837 the mass of a proton. We can say that the mass of 1837 electron is equal to the mass of one proton, right? If you take 1837 electron, 1837 electron, and if you add the mass of all these 1837 electron, then their mass will be equal to the mass of one proton, right? So this is what I'm trying to say. If you take 1837 electrons, then their mass will be equal to one proton. So it is written over here, the mass of one electron is equal to about 1/1837 the mass of a proton. We can say that the mass of 1837 electron is equal to the mass of one proton. Okay, so you need to also remember this, right? So from these all above things, we can write this thing. Thus, one proton is equal to one neutron. Here it is written the mass of one neutron is equal to the mass of one proton. Aryan, one proton is equal to one neutron, and the one neutron is equal to 1837 electrons. Like I told you, 1837 electrons is equal to 1 proton. So we can write 1837 electron is equal to 1 neutron, and this 1 neutron is equal to 1 proton. So these three things are equal, and these all things are called 1 AMU. The mass of 1 proton, or the mass of 1 neutron, or the mass of 1837 electrons, these are called 1 AMU. So this is 1 AMU, right? P1 proton is equal to 1 neutron is equal to 1837 electrons, and that is called 1 AMU. Proton and electrons are charged particle. The electric charge is measured in coulomb C. Okay, the proton and electrons are, let me just zoom out a little bit so you'll see this. Okay, I hope you can see the board. Here we have protons and electrons are charged particle. They have proton, they have positive charge, electron, they have negative charge, so they are charged particle. The electric charge is measured in coulomb C. 1 coulomb is equal to 6.25 times 10 to the power 18 ESU, which is equal to the charge of 6.25 times 10 to the power 18 electrons, right? So this ESU means electrostatic unit. So that was it for this video. I hope everything is cleared about atomic mass unit. The next topic will start tomorrow. Will be a little bit about, only a little bit is left about this topic, atomic mass unit. And that's it for this video. If you are new here on this channel, first take this screenshot, and then that's it for this video. The next video will come very soon on this channel about the next topic will be electronic configuration of an atom. Okay, so maybe tomorrow we'll start this topic. So if you want to learn the science, and then you have to subscribe to the channel. That's it. See you soon. Make sure you subscribe our YouTube channel and turn on the bell icon so you will get the latest video that we will upload on our channel. Okay, that's it. See you soon.